Okay, our next problem involves two fractions which are created or made up of expressions. And it seems like there's a lot going on here, but once you see the technique in order to simplify this, then you should get the hang of it. First and foremost, if you can recall, whenever we had fractions before and we divided them, there was a process called keep, change, flip. Keep, change, flip. Basically telling us to keep the first fraction the same, change the division to a multiplication, and then flip the second fraction upside down. So that's what we want to do. We want to keep the first fraction the same. We want to change it to multiplication, and then we want to flip the second fraction. Now that we did that, we can take it piece by piece. So the numerator, I see I have a trinomial, and trinomials that you see majority of the time, they'll factor out into two binomials. However, this is a special type of trinomial because the 2, the -8, and the -42 all have a common factor. So I want to take the factor out before I even try and put it into two binomials. And that's going to be the trick, because some people try to jump into it and just go forward and make two binomials. So I want to take out a 2. I'm left with x squared minus 4x minus 21. I do not factor my monomial. I've seen that done before where students try to factor this monomial into two binomials. No, 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 no. Let me go on the right. I have a binomial that I can actually factor out an x. And I took out an x, and I'm left with x parentheses x minus 3. And if you work backwards mentally, x times x is x squared, x times -3 is -3x. Okay, now we have this x squared minus 9. This is called a difference of perfect squares. So one would be x plus 3 and the other would be x minus 3. So we basically took our pretty hefty problem from the top, changed it to multiplication, then went and factored it as best we could. Now there's one more step here that we can actually do, and you probably picked up on it. So 2 can now be broken down into two parentheses. You're looking for two numbers that when you multiply them give you -21, but when you add them you get -4. That will be x take away 7 and x plus 3. Everything gets brought down. And this is actually the fun part. You get to cross out any common binomials or any common terms. So I see I have an x minus 3 here. I want to cross that out with the bottom. I can cross out the x plus 3 with this x plus 3. I can actually cross out the 2, simplify the 2 and the 6. So 2/6 is really 1/3, right? And then the x up here, and there's two x's down here, so I'm left with just 1x. I know it probably looks kind of confusing, but let's just put our final answer together and maybe you'll be able to see it better. The only thing left at the top right now is the x minus 7 And at the bottom we have the 3x. So this would be your final answer. And of course, the reason why we go through this whole process is x could actually stand for a number. So if I told you that x was 5, and I said, find out the answer to this problem, you would actually have to take the number 5 and plug it in every time you see an x. But now that you simplified it all the way to x minus 7 over 3x, you can actually take the 5 and just plug it down here and you'll get that same answer. So that's why we actually try to simplify expressions.